Thanks everybody for coming to this session. It's a great turnout to see everybody. Quickly, show of hands. Who here is already using Kubernetes? Nice, so most of the room. And who here is using Kubernetes on Spark already? Successfully? Ish, yeah, okay, that's just presentation. And who here maybe just had a boss that came to them and asked them, hey, what's your Kubernetes strategy? And then you quickly tried to figure out how to spell Kubernetes, you could Google it. Okay, that's me. I'm in that camp. And that's pretty much this presentation 6 to 9 months ago, figuring out, hey, what's our Kubernetes strategy? Where's this thing headed? You know, we got a good thing going with Yarn, but let's start looking at Kubernetes. This is basically talking to a lot of different developers and playing around myself. So when your boss comes to you and asks you that same question, hopefully this gives you a little bit of a jump start, at least to kind of see where things are headed. So quickly, just to introduce myself, I'm Chris. I am from Google. Most of you probably, when you think about Google, think about that website where you go and search for things, or, but you know, also behind the scenes at Google, what powers a lot of that search are all of these data centers and a lot of compute processing and a lot of tools that we've developed and published papers about over the years. And so what we started to do now is take a lot of those tools that have powered things like Gmail and other applications that Google has, and we started to release those as part of Google Cloud. And so we now have a lot of different enterprise customers that are using Google technologies that we've exposed to the outside world that we've really battle tested within the walls of Google. And so, you know, open data and solving big data problems is not new for Google by any means. We've been doing it for about 20 years, starting with originally, you know, we were the ones that wrote the MapReduce paper that turned into Hadoop, Dremel, which is kind of turned into Apache Drill, but also now BigQuery is the externalized version of Dremel that anyone can go use as a serverless data warehouse. And I'm not going to go through the whole list, but to get the idea that we've been doing this for a while and even still continue to do this with newer releases like Beam and TensorFlow that we give back to the open source community. What I do at Google is I'm a product manager, and I cover our GCP data ecosystem. Which is the services that we basically take for open source, and we help you by managing those for you. That includes Cloud Data Proc, which is Apache Spark and Hadoop, Cloud Composer, which is Airflow, and Dataflow, which is Apache Beam. Data Proc is going to be the most relevant to this conversation and probably this group of users. It is our managed cloud service for Apache Spark and Hadoop. It gives you really rapid cluster creation. You can have an entire an entire Hadoop or Spark cluster up and running in about 90 seconds. It gives you a lot of the same familiar open source tools, even though you're doing a lot more in the cloud. You get customizable machine types, so if you need to have, you know, this set of jobs runs on very memory intensive clusters, or you have a set of machine learning jobs that need compute heavy clusters, no problem, 90 seconds, get yourself a cluster, and you can customize those cluster types to whatever you need. And a lot of tools to make having ephemeral and on-demand clusters much easier. We have things like workflow templates that let you specify a YAML file of exactly what you want your cluster to look like, a DAG of jobs that you can use on top of that cluster, and then we'll make sure that everything gets torn down for you. And then we try to tightly integrate with a lot of other Google Cloud services, things like Spanner and BigQuery and the products that you may have seen on the previous slide. So it's not just a standalone Hadoop cluster, but it's really integrated with a lot of these other cloud products. And last year alone, this is still an area we're heavily investing in. Last year alone, we've had 30 new features that really we're trying to make things fast, easy, cost-effective. I could do a whole presentation, and I have whole presentations on this, but I want to jump in. I'm going to skip past this because I want to get to the Kubernetes stuff. Because Cloud Data Proc, behind the scenes, and this is kind of where the Kubernetes starts to kick in. It's behind the scenes, the way we actually do Cloud Data Proc is we have a control plane, and then we have the data plane. Now, when you're in user land and you come in to, you know, submit a data proc job, we take that into our control plane. We have a set of basically Docker containers that are running on Google Borg. Borg is our internal name for basically Kubernetes. It's where Kubernetes came from. A lot of the concepts in Borg got turned into Kubernetes, but essentially to us internally as developers, looks and feels a lot like Kubernetes. And so this is what we've been doing for years to manage Cloud Data Proc's control plane, keeping track of these jobs, keeping track of these clusters, you know, solving problems when the cluster goes down. It's a set of microservices backed by a spanner database. Now, on the front end, what you're seeing is just your traditional Apache Hadoop yarn. That's how we actually are calling into Spark and MapReduce and Hive and Pig and all of that. And so this is great. We had our two different worlds, but then they kind of collided when Spark 2.4 came around, and they introduced this idea of actually using Kubernetes as a scheduler. And so this, of course, prompted, hey, as a product manager, we're pretty good at running Kubernetes. That's how our control plane works, and we're pretty good at managing yarn. But what does this new world kind of look like? And so to answer that question, what I'm going to do today is just back up all the way to the start for Kubernetes for a lot of you. This might be a little redundant, but I do want to set the context for exactly what is Kubernetes before we get to how could it help, because then it might give you a better indication. So the most basic thing is Kubernetes. You might often see it abbreviated as K8. It is an open source project. It came out of that Google Borg that we just showed. And it's now developing really rapidly in the ecosystem, a lot more than just Google is working on this. It's really a cross-company collaboration for cloud management. Now, if you go talk to a Google Cloud sales rep, this is probably how they describe Kubernetes for you. It's this magical API, and then you can do all these things in the cluster. But I'm going to dig a little bit deeper than that to give you a better idea of what's actually happening here. So what you're going to end up having is a set of API services that live on a master. And those call into a series of nodes or kubelets that run on various nodes. So you can go, and that's what actually, the master is what schedules various containers and applications and manages your resources. But all of this you can connect to with APIs, which is great. And one other concept to keep track of is a container cluster. So if you're in the cloud and you're using something like the Google Kubernetes engine, or even if you're on S3 or IBM, they've done a lot of tie-ins to hide some of the hardware. So you don't have to deal with virtual machines, you only have to deal with the Kubernetes APIs. And so that concept is this concept of a cluster container where you might be dealing with just Kubernetes, but then it's tied in the back end to things like, hey, if I want to create a service, it knows to go and use the Google Cloud load balancer, but you as an end user wouldn't have to deal with that. You can just stay in Kubernetes land. So that's the idea of a container cluster. So now that we have that idea in our heads about how this infrastructure is kind of mapped and laid out, it's good to understand that Kubernetes does work off of a master endpoint. That's your gateway into the cluster. That's where all your APIs live. You're typically going to hit this with either a kubectl CLI command or through API calls. And what you're doing on the last thing, the way this ended was, this is going to these API calls, it's what scheduled pod creation deletions onto nodes. And so what is a pod is something that comes up pretty quickly. And when you hear the term pod in Kubernetes, think application. Usually it's a set of microservices, a set of web applications that are all sort of tied together. Even in the world of Spark that's pretty self-contained, you might still have like an Nginx load balancer that sits in front of things, and that combination is your pod, things that are designed to run together. So you have single networking, and then even you might have shared disk storage. So if these different microservices are all one application, need to access the same data, you just keep it all in the same pod. And so you keep that concept in mind. And then typically what you do is you take that pod, and that pod gets scheduled onto nodes, which are the actual physical VMs. So now we've gone all the way from that, that nice vision of, hey, I have this nice cloud, I have this API call. Here's reality kicking in a little bit. It starts to look a little bit more complicated, where I have these, API masters. I'm scheduling different, networking and data storage services. This graph shows them outside of the cluster. They actually do live on the nodes, but the point is there's a lot of complexity that gets built up pretty quickly if you're trying to actually do things in Kubernetes. Now, because this is all API calls, this is all, things that you can automate, people have done that, and that's been great. So an open source team at CoreOS, they were recently bought by Red Hat, who I guess is part of IBM. They started this thing called an operator. And an operator, it's just a way to package up. Think about it as like, Yum or apt-get, but for Kubernetes. where you can have a whole host of services and start to, in Kubernetes, just do a simple deployment that will automate that entire, that last slide that you just saw. And so you can start to take advantage of these applications in their more native format. And this, maybe a yarn translation would be to think about like the Spark job server or Livy, where you just, submit something and you don't have to worry about that underlying layers. So tying back to Spark is there are Spark operators for Kubernetes. The one I'm going to hit on today is the one that Google released, but to be very clear, it runs great on Google Cloud, has a bunch of tie-ins, but it will also run on any Kubernetes deployment anywhere. It could run on your laptop, it could run on IBM, it doesn't matter, it's agnostic. So what this operator is going to give for us, it's going to give us an integration with some of the Google tools that you might also want to use. It'll give you a replacement for HDFS, so you don't have to deal with running HDFS on a Kubernetes cluster. You can just basically use cloud storage. It'll connect you over to there. And it's going to deal with some of the logging that can get a little bit complex. And essentially, at the end of the day, what you get is now you have, instead of a kube control operator, you get a Spark control operator, which just feels a little bit more like a native Spark. And so you're just dealing with things that are at the Spark application, and you don't have to necessarily go in and get into the guts of Kubernetes to start using Spark on Kubernetes. So with that background, I'm going to walk through the operator really quickly, and as we go along, I'm going to try to give some of the background that maps to what's actually happening in Kubernetes to give you an idea of how Spark on Kubernetes and this operator actually works. So first thing we have to do is we got to deploy this thing. There's two ways to do it. If you're on Google Cloud, we do have a marketplace that makes it really one-click deployment through our marketplace. But then there's also this idea of a Helm chart, which is more universal. And it's a great way to deploy applications into Kubernetes. Essentially, it's a client and server-side application. Client side, you'll load up and say, hey, here are the applications I want. On the Kubernetes server, there's on the Kubernetes cluster itself, there's a server called Tiller, and then those two talk, and that's how you can quickly deploy applications using Helm. So real quick, this is the Google Cloud console if you've never seen it before. So I'm going to do this through Google Cloud, but again, the things that I'm showing could be done on any cloud or on-prem or even on your laptop using Kubernetes. It's just Google Cloud's a great way to get started here. So this operator is one way, this marketplace option is one way I could quickly throw off the operator onto a cluster. All I'd have to do here is pick my cluster and then say where I want it. But I'm actually going to take the long route, just so if you're not in Google Cloud, you can see how this would work anywhere else. And I'm going to use a Helm chart. So the first thing I did is I came into our Google Kubernetes engine, and this is that idea of a container cluster. We're using the service. It's going to map all the Kubernetes APIs to Google Cloud Infrastructure, and I don't have to worry about infrastructure anymore. I just speak Kubernetes, and I can go from there. So I've created this analytics cluster. It would be designed for memory-intensive applications. That just means what the underlying nodes look like. And in a minute here, this will spin up for me, and I'll have I believe, a 3-node cluster. And now you can see I am up and running this Kubernetes cluster. And what I want to do is I'm going to click that connect button. And all that's going to do is it's going to give me a command line that I can use to pull the authentication from my cluster into the command line and associate the kube control command with this cluster. So you'll see that real quick. That's just all I'm doing is I'm already authenticated via OAuth and myself, and now I'm just saying, hey, there's my endpoint, there's my cluster. So now every time I type kube control, I'm talking about this cluster that I just created. And so I can double check that just with a cluster info, and I can see that, hey, my master's up and running, and so are a few other services. Hey, everything looks good. I have myself a Kubernetes cluster. But I don't have Spark yet. So before I even can get to Spark, what I did here is I gave myself admin privileges. I need admin privileges to the cluster so I can start to deploy things. And I'm going to install Helm. And you see here, I tried to install Helm. I don't have Helm yet. So shout out to Jonathan Campos. He actually has a great post that walks through exactly how to set up Helm on GKE, and it's better than any of the Google Docs. So if anyone knows him, give him my thanks. But yeah, I just take this script, and you'll see now I'll run this script which will do the Helm install on GKE for me. And there you go. And now we're actually going to install Helm. So I'm going to get Tiller as a server on that cluster I just installed. And the reason why I'm doing this again is because that's my package installation manager for my Spark operator. So then I don't have to manually do things with the Spark operator. All right. So now I have Helm installed. I'm ready to go. And so at this point, I'm going to go into, I've already pulled this down from GitHub, but I'm going to go into my K8's operator. And anyone that's using the operator, one quick thing you might have to do on Google Cloud, not all the authentication in Helm gets set up correctly, so I manually apply this Spark RBAC command. Just a pro tip for anyone trying to do this. You'll need to do that separately. Don't worry about what that apply means. I'll talk about that more in a little bit in the context of the operator. But essentially what I'm doing here is I'm just doing something that Helm really should have done for me, but it didn't have permissions to. So now that it's created this role binding, I do want to talk about what that deployment actually did. So when you have these workloads in Kubernetes, those could correspond to various types of applications, whether it's stateful, stateless, batch, whatever. And what happens is the Spark operator is going to use the concept of a deployment. So a deployment describes this like desired state of what you want. So it's easier to think about first in the context of like a web application where you're like, okay, I have this web application. I always want it to have 3 nodes and load balanced. And so I'm going to declare this deployment that says, here's the state of the world that I always want. If you notice something's wrong, go ahead and repair that for me. And that's the idea behind a deployment file. And that's essentially what the Spark operator and Spark on K8 does for us, is it makes basically a Spark submit look more like one of those deployments, and so it'll check that everything's up and running. Now that concept does get a little kludgy if you're used to using Spark submit and used to using like, these implicit, like I'm going to send this command off and it's going to do its thing. Now you have to kind of shift your mindset to like, yep, that command is going to be doing things, but it's going against this deployment that's constantly going to be checking for, the state of the world. And these deployments, it's even, if you want to break it down a little bit more, they're built with just replica sets, which is another Kubernetes concept, which is just a fancy way of saying, hey, how many things do you want running? And so this is the most basic example of a replica set. It would be like a hello world application, where all I'm defining is a selector that makes it so when I come into kube control or a Kubernetes cluster, I can say, hey, how many of these hello applications are running? That's that selector that you see. And then there's a number indicating how many of these pods, how many of these applications should be running at once. And this will always be the thing that gets checked to say, hey, do I have 3 of these replicas going? If not, create one. Or, hey, there's too many, delete one. And then finally, this is kind of where the rubber actually meets the road, is you're also here is where you're going to define what the actual image is. So your Docker container that actually has your code, the thing that you actually want to run and care about, this is where it gets defined. And then what happens is this replica set, it creates pods until you have the right number of replicas or the right number of those Docker files running on your behalf. So now that we kind of understand what that is, let's go ahead and kick off a actual job on a Spark job on Kubernetes. So just to give you, what I'm going to do here is I'm going to pull this up in the Google Cloud text editor, just because it'll be a little bit easier to see than pulling up VI or something. And you can see what the actual YAML file for the Spark operator now looks like. So you can see here's the API version I'm using, which is our Spark operator. Then I'm going to go down and I'm going to say, okay, here's the image that I'm actually going to use. That's the Docker container. This is the standard one that comes with the Spark operator. It's based on the standard one that comes with Spark on Kubernetes. And then you can see in the YAML where I'm actually defining, here's my driver, here's the executor, here's how much memory I want, here's the version to use. Volumes are like the data storage. I'm not actually mounting those properly, but that's essentially how it would work. So with that, now that we kind of have an understanding of what this looks like, let's kick it off. And so again, the way this works is we're going to specify it as a deployment that says, hey, here's the state of the world, here's what I want to be running. And so we're going to go ahead and do that kube control apply. And what the application I'm running here is just the most basic thing I could, which is just we're going to calculate pi. And that's what comes with the Spark operator is standard, so you can go calculate it. So coming in to check my workloads, again, these are my deployments that are out there. You can see the drivers spun up. And I also spun up 2 services. Services we'll talk about more in a little bit, but essentially these are the web interfaces into the cluster. And so I'm going to go and take a look. If you can see that the status here did succeed, so I can go look at this driver. And I'm going to take a look at the events. What actually happened here, you can see I didn't set up the mount properly, no problem, but I did create this pod, and I pulled down my image successfully. I pulled it, and I ran the job, and what I'll do here is I'll check my log files so I can actually see what happens, and we'll go right to the container logs. At the top here, all you're seeing is a set of filters that you could apply without having this UI, but the UI just gives you a nice way to click directly through, and you can see in my logs, I just calculated pi in probably the most complex way possible. And so the other piece before we leave the operator is one nice thing that happens with Spark on Kubernetes is Kubernetes has this idea of a service. Now that, again, let's back up to the web world. If I have a web service, I probably don't want to expose all my underlying databases and everything in the pod. I probably just want to expose my load balancer. So what I do is I set up a Kubernetes service on top of that load balancer, and that way I always know the IP addresses that are coming in. In Spark, the thing I probably want to get into is that web UI. And so what makes it pretty nice is this ability to have a service automatically set up so I can get into that Spark UI. So I'm going to change the name. I'm going to send off essentially the same job. I'm going to change the name, increase the memory a little bit, just so it runs longer and we can test this. And I'm going to throw this, I'm going to kick it off again. Same calculating by Spark job. And again, we're going to apply that deployment. I'm going to say, hey, here's the state of the world I want here based on the information in this job. Great, created the job. And now what we're going to do is we're going to come back in and take a look at the services that were set up automatically by Spark on Kubernetes. And we'll look for our application name. And what I'm going to do here is this is running within my GKE cluster. And so all this is that's a little cheat that is going to do some port forwarding for me. So I'm still going to go over SSH to open up these web ports, and that's all this is doing. It's nothing magical. It just gets me into the web cluster in an easy way. And that way I can open up this web port over SSH. I initially get an error here only because it takes a little bit for this service to actually get spun up when you're using the operator. But very quickly now, there it is, and that is the very same Spark UI you've seen everywhere else. It's just now exposed as a service, so I still have an easy way to come in and get some of the familiar tools that I'm with. And essentially, you could do the same thing with if you're running a notebook, you would do the same thing yourself by setting up a service for your notebook interface, and then you could quickly come in, connect over SSH to get to those notebooks if you're trying to run this in client mode. Looking at the environment very quickly, just so you can see, there's all the different Kubernetes settings that were, passed along. And then I can see the executors, which actually run on different pods in the driver. So you have your driver pod, then you have your various executor pods, depending on how many I specified in that YAML file. All right, so now we're going to get into my, some of my takeaways and my first impressions now that you've seen kind of a better understanding of maybe if you haven't been familiar with that, or even if you were, let's talk a little bit about, so the first question I always get is from a lot of my customers is this ready for production? And then my answer is always kind of like, well, what are you doing in production? Like, what is your production? If it's calculating pi, then this might be okay, as long as you don't mind that the driver sometimes goes down and you get no error messages as to why. But more realistically, there's a lot of folks working on this. A lot of companies are invested in this. So I do expect this to change pretty rapidly and to get a lot more mature. And so as I think about just a little bit ahead, where are the differences between Kubernetes and Yarn, and what are some of the advantages we could probably get? So first of all, with Kubernetes is a lot of folks, a lot of you raised your hand in the beginning of this talk that you're already running Kubernetes applications. Maybe you have a lot of web applications that are running, but at night, you want to take advantage of the cluster resources. That's where this could be really good. But if you're not already running Kubernetes and you have a lot of Yarn stuff set up, well, that might not be as helpful because you already have everything built around Yarn. A good point is data scientists, developers, they can tap into those on your resources, again, assuming you're using K8, but you're not at full utilization. Bad part is if I'm going to convert a lot of users or data scientists from Yarn into Kubernetes, I might have to be rethinking about some of those Yarn queues work and a lot of the work that went into developing different groups and how they get assigned in Yarn queues. You're going to have to now rethink that for Kubernetes and start managing the resources in Kubernetes. A good thing is developers can use these custom configurations, even if it's like at the OS level. So if you have some crazy Fortran dependencies, you can get away with that by putting into these Docker images and letting it run. On the other hand, keeping track of all of the logs that are associated with these developers who are now able to do what they want could get a little bit more complex. It's pretty straightforward in Yarn. I'm imagining most larger companies, they already have their logging system set up to pull down your resource and your node manager logs. But now you're going to have to redo that for Kubernetes. Just another thing to worry about. Again, this is kind of similar to my last point, but the package containers, it's great. Developers can do what they want. They don't have to deal with these, Conda environments where there's an admin that has to control what's going in and out of that. You can have really targeted upgrades. You can say, this version of Hive, this version of Spark, these dependencies, all package that up into a single container. But the flip side of that now is developers, they have all this freedom, but now they might end up with a little bit more responsibility than they had hoped for, because in Kubernetes, now they're going to have to worry about things that they didn't have to, like setting up networking if there's some complex networking environments or whatever it might be. And you can probably resolve some of these over time with like templates, but initially, it's going to fall on the developers to figure this stuff out when they didn't before. You can break out users into really distinct workloads, isolate them based on memory and CPU, similar to what you were doing in Yarn queues, but a little bit more in Kubernetes. But you're going to have some issues with stateful data. There's volume support, but not a lot has been done in that space, I think, yet. I think there's a lot of folks working there, and that'll come, but it is a little bit of a gap today. You can mitigate a lot of that by going and using cloud storage as your source and sink, so you're not writing to local volumes on Kubernetes. Secret management in Kubernetes is pretty cool. So within the idea of Kubernetes, like for every job that you can have an independent key that is seen by it's not seen by the administrators, that only the job knows about, and it is very scoped to just the permissions that job needs. And so that's great. Flip side is, if you look at the overall security infrastructure here with Kubernetes, it gets pretty complex really fast, because you have to think through like, all right, well now am I passing over my Kerberos, and then that lives within Spark, but then I also have, Kubernetes RBAC controls that are controlling another set of permissions, but then it's on an actual VM, and that has like a service account and its set of permissions, and the VM service account lives in Cloud IAM, and maybe that's backed by an Active Directory, and so you just end up in this whole wormhole of like security and trying to track stuff down, even though at the user level, you can do some pretty, slick stuff. You can scale to 0, so if you want all the data scientists off of that cluster, no problem. You can have all the resources dedicated to whatever the applications are otherwise. But again, this relates back to the volume issue. We're seeing really bad shuffle performance right now, even though there's a lot of work in flight to address this. So with that, I'm going to stop and open it up for questions, and just to hear more about like what folks' first impressions are if they've started to experiment with some of this and what they think some of the advantages might be.
You showed the Spark UI. Is there also something like a history server available?
Yeah. I think by default it only sets up a service for the Spark UI, but anything that you can have a web application into, you can create a service for. And so you could have, if you're running a Jupyter Notebook, you could create a service for that. The service is just about basically having a standard IP address in, so when things underneath the hood shift around, you don't have to worry about like doling out new addresses. It just keeps things consistent.
What is the state of Kubernetes elasticity regarding Spark? Like if I have a small Kubernetes cluster and I deploy a big Spark job, is Kubernetes going to be able to detect that and scale automatically, or is Spark not yet configured for that?
No, it will do that. So you can set up the scaling and the scaling resources. And then if you're using that container cluster scenario where like you have a cloud provider that is attached to Kubernetes, then it's smart enough to know, hey, I'm requesting too many resources from Kubernetes, and then it'll actually scale underneath the hood. Where there's issues with shuffle still is it gets harder on like downscaling. Because in downscaling, like if you think about Spark, it was always designed around the idea of like I have a set of resources, I have a cluster at my data center, and those computers are not going away. There might be a failure, but I'll resolve from like one computer failing at a time. Where in cloud, you might have a whole host of computers that disappear at once, right? Because it's more ephemeral in nature. And so Spark is not necessarily great at handling those big downscales. And that's where things like the external shuffle hopefully will come in and give you an external place to put shuffle. So then you can handle these bigger downscales. So up is usually pretty good. Down can be bad. All right, if there's no other questions, I will hang around. But other than that, I guess we can wrap up early.